Okay, we are starting, oops, completing the square. Now, completing the square is turning it from standard formula into vertex formula. Is that correct? Yeah. The only difference is these ones are going to start to get really difficult, right? This is the ones, remember we were talking about graphs before, we were saying, hey, solve for the zeros, solve for the x-intercepts. And I said, you don't have the skills to do that yet? Well, now you're going to learn some of them. What's going to happen is once these get really hard, then we're going to switch to what's known as the quadratic formula, which is on Wednesday. Okay. Now, when you take the square root of something, and this is from the mental math. Remember when I asked you, hey guys, what's the square root of 64? Normally in the past you would just say 8, is that correct? But then I said, no, there's more to it than that. Is there a positive and a negative? Because negative 8 times negative 8 is positive 64. Okay, so when you're looking at this, you can have two answers, right? So we can do this, and to solve for x, right, we take the square root of both sides, while the square root of x squared is just x, square root of 64 is plus or minus 8. So there's two possibilities for answers. So, yeah? Okay. So we can use this basic knowledge of solving for x to actually solve for equations. Now the only thing you're going to have to worry about, and this is coming up, and you've seen this already, we introduced this before, is sometimes when solving an equation, you're going to get an answer that you need to actually help you solve the equation, but it's known as a extraneous root. Remember, that was like negative distance. Could we have negative distance? No. Could we have negative time? No. Those are all known as extraneous roots. You need them so you can solve the math, but they're useless. Okay. So let's go right into an example. So you got a widescreen TV. Now this is, pretty much all TVs are widescreen now, right? It's like going to the movie theater. They're wider than they are taller, right? So what it is when they measure TVs, when you say, hey, I got a 42-inch TV, they're actually measuring the diagonal, right? That's the distance from corner to corner is how they measure the distance on a TV in the screen, right? So if you have a 30-inch TV, it's 30 inches from corner to corner. A 42-inch TV is 42 inches from corner to corner, right? So the width of the screen is 16 inches more than height. So what we want to know is we want to determine the dimensions of the screen, right? We know it's 42 inches on the diagonal. We want to find out the overall dimensions. So what do you think we should do to start this question? Draw a TV, draw a picture, right? It's a rectangle, isn't it? Is it wider than it is taller? All right, that should be a little bit of a hint there of what we're doing here. So it's wider than it is taller. There we go. Do we know the diagonal measurement? What is it? 42 inches. Okay. What letter should we use for height? H. Good choice. Now, the width of the screen is 16 inches more than the height. So how do we create the width of this TV? For instance, if the height was 10, the width would be 26, right? Is that correct? Because it's 16 inches more. If the height was 5, not X, what letter? H plus 16. Okay, good. Does that make sense? Now, what we want to know is we want to know what height is. But the problem is this is not the area, is it? That's 42. Well, what shape is this right here? The whole thing's a rectangle. And what kind of triangle is it? It's a right angle triangle. Oh, so there's actually a box in that corner, isn't there? Huh. A right angle triangle. There's this fancy formula we use about right angle triangles. What is it? Pythagorean theorem? Pythagoras? Pythagorean theorem? What's the theorem? The square of the longer side of the hypotenuse is equal to the squares of the other sides added together. Is that correct? Huh. So let's do that. So what you're telling me is the square of one of the sides, let's do h squared, right? Plus the square of what? h plus 16 squared equals, what does it equal? 42 what? Squared, right? Don't forget everything has to be squared, right? Because that's the basis of Pythagorean theorem, right? Well, this is just algebra, right? We're just solving for h, aren't we? Because once we know h, then we add 16 to it, and we'll know the width of the TV. So what do we do here? Do some math for me. Well, I can't do anything with that. What about that guy, though, in the middle? What is that? Is it two binomials? Can you FOIL it? Can you FOIL it in your head? Nod your head. Yes, you can. Now watch. Let's do this. So think about this. This is h plus 16 times h plus 16. What's h times h? H squared. H times 16 is 16h. You're going to add those two together, right? 16h and 16h is 32h. Okay, that's the center part. And 16 times 16, 256. Okay, so plus 256. Equals, no, I can't do 42 squared in my head. 1764? Okay. Well, that's just basic math, right? Guys, you see that. That's two binomials. If you need to, could you write those two binomials out side by side and do your FOIL? Yeah, you can do all that, right? But you should be getting beyond that stage already. Now, how do we solve for this? What is there anything we can combine? Oh yeah, sure, why not? We can put the h squared together, right? What's h squared and h squared? 2h squared plus 32h equals 1764. Well, that's not bad. That's a little bit easier for starters. Sorry, what? Yeah, talented, eh? Well, what can we do with that 256? Yeah, we can. Let's do that for starters. So you want to subtract 256. So you subtract it from both sides. So what is that? 1764 subtract 256 is, what is it, 15? Oh, 8? Yeah, it works. Okay. What else can we do? Before I'm talking before, like, what's the title of this, by the way? Okay, obviously we're going to complete the square, aren't we, in a sec. But let's do some more stuff before we even get to that stage. The key is if you can simplify this stuff as much as you can before you do completing the square, it saves you a bunch of work. What can you do? Before you even move it. What does that end in? What does this end in? 8, 2, and a 2. What can you divide by? Could you divide everything by 2? Sure, why not? So basically take the whole thing and divide it by 2. Right? So what do we end up with? h squared plus 16h equals 750 plus 4. 754, is that right? Okay, now, this is interesting. When we completed the square before, what did we make it equal to? We made it equal to 0, is that correct? What did you do then? Think about what you did. What did you do with this 16 here? You took it and divided it by 2 and then squared it, right? So what would that be? 16 divided by 2 is 8, squared is 64. So normally what we would do is we would add 64, and then to keep it in balance, we would also subtract 64 on the same side of the equation. Is that correct? Think about this for a minute. If we didn't want to keep it on the same side of the equation, for instance, if we added 64 here, because there's an equal sign, what would we have to do on the other side of the equation? Add 64. Is that correct? So the only difference is because we're on the other side of the equal sign, you have to keep it in balance, you do the same thing. So technically there's two ways of doing this equation, right? We could bring the 754 over to the other side, make it equal to 0, do it like we've normally done, right? But here's another option. Could we leave the 754 on that side? We could. Do you want to try it that way? Yes, we do. Because you're going to have to do it this way anyways. We could try it. Okay, here's the deal. If you don't want to do it this way, move the 754 to the other side and complete the square like we normally do. The only difference is if you add it, you have to subtract it. If we keep it on this side, you'll see in a sec what I'm actually talking about here. Okay, this is a different way to do completing the square. It's still the same principle, but the only difference is the 754 is on the opposite side. It's not always equal to 0. You'll see in a minute why we do it this way, or why I do it this way. Okay, normally what we do is h squared plus 16h equals 754. Now, remember when I did this before, those two lines were on the same side of the equal sign, right? They were all on the same side, it was all equal to 0. The only difference is that I'm going to keep it in balance. I'm going to do something on one side, do something on the other. Okay, so the procedure is still the same. What number are we taking and dividing by 2? 16, is that correct? I'm taking the 16, I'm dividing it by 2, and then what am I doing with that? Squaring it. So 16 divided by 2 is 8, squared is, what number is that? 64. Okay, now here's the cool thing. If I add 64 here, what do I have to do to the other side? Add 64. It's different than the last time. Last time the signs were different, right? Because they were on the same side of the equal sign. So to do that, it has to keep it in balance. Here, if we add 64 to one side of the scale, we add 64 to the other side of the scale. That's the only difference. Right? If you did it with the 754 over here, you would do it exactly like, what was your first step? You said, bully the 754 over a bit, right? But you still do the same thing. You take the 16 divided by 2 squared. But you'd add 64 and subtract 64. Okay, so now let's do the math here. Now, this is basically a binomial, isn't it? H plus... Do I need to do it as two binomials again? Because you might have forgotten this. Do I need to do it this way first, two binomials? H plus 8, H plus 8, is that correct? Equals, what's 754 plus 64? 818, is that right? I just added those together. Is that what you're asking? Okay, what is this combined? H plus 8 squared equals 818. Okay. Now, if you did it the other way, this 818 would be on this side and it would be negative, wouldn't it? Did anybody do it that way? No? All right. You'll get used to seeing completing the square both ways, right? One on one side, one on the other. Now, look back at the top of the page. How did we solve this? 8x squared equals 64. What did we do? Took the... You did that. Did we take the square root of both sides? Yeah? Okay, now look. Apply the same concept here. We have a square. How do we get rid of the square? Take the square root of both sides. Is that correct? Is that right? Okay. Now watch. What's the square root of h plus 8 squared? H plus 8. That's all it is h plus 8. Equals. Now careful, 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 careful. What was the square root of 64? Plus or minus 8. So what is going to be the square root of 818? Plus or minus whatever the number is. Now, can you take the square root of 818? Is it a nice number? No, it's an ugly number, right? So what are we going to leave it as instead? Plus or minus the square root of 818. You just leave it as that. Now, how do we solve for h? We're going to get h by itself, right? What do we do with this guy? Subtract it from both sides, is that correct? So, okay, let's go one step further. H equals negative 8 plus or minus 818. Two answers. One of them is negative 8 plus that. One of them is negative 8 minus that. That's the two answers. So let's actually figure this out decimal-wise because we want to actually see what the numbers are. So one of the answers are, right, we can split this. There's two possible answers. One of them is negative 8 plus the square root of 818, and one of them is negative 8 minus the square root of 818. Okay, grab your calculator and give me those two one decimal place. Hang on. So the plus one, this one here, is 20.6. I think this is inches as the units we're in. Minus 36.6 inches. The squiggles mean it approximately, right? This is kind of like when we set it equal to 0, wasn't it? When we set it equal to 0, didn't we just solve for each side, make it equal to 0? That's all we're doing. We're just solving for h in this case. Okay. You have two answers. What can you tell me about these answers? Why is the negative one an extraneous root? Can you have negative distance? Yeah, my TV is negative 36.6 inches high. What? Can you have negative distance? No, you can't. But did we need that number to do the math? Yeah, we need it in there. So this right here, this guy here, can happen. That's called an extraneous. If I could spell, that would really help. Extraneous root. Okay. So if we have a 42-inch TV on the diagonal, how tall is the TV? 20.6 inches. So could we figure out the width now too? How do we figure out the width? Take the 20.6 and plus 16. So what's our width? 36.6 inches. Okay. So when you think about when they actually say, hey guys, I have a 42-inch TV at home, the height of the TV is 20.6 inches, the height of the actual screen. The TV might be more, right? And we're talking about the screen, right? So for instance, like on the smartboard, this diagonal here, from the corner to that corner, then we would measure the height, we can measure the width. Okay. And the height is 20.6, the width is 36.6, and the diagonal is 42. That's how you figure this stuff out. Have you ever looked at the back of a DVD, and they'll have aspect ratio? You ever notice that? And it says widescreen, right? Have you ever seen that? There's actually two sets of numbers that go with it. I don't know if you've ever noticed it. And actually, I think there's on Global, there's a TV show called, is it 916? Is that what it is? No, 16, what is it? 16:9. That's what it is. 16:9, like that? Do you know what that is? It's called the aspect ratio. 16 inches wide, 9 inches tall. That is a widescreen. So in this case, 20.6 tall, 36.6 wide. The diagonal is 42. It's a widescreen TV. It has an aspect ratio of 9 to 16. It's just a common way of doing math now. Okay. Now, just look back here, guys. If you don't like the way I did this, could you move this 818 onto, the 754 to the other side and complete the square? The only thing you'd have to do is then to figure it out at the end, you'd have to move it back to the other side. So is it 2 extra steps? Yeah. Could you do it that way? Yeah, it doesn't matter to me. Okay, flip page. Do the next one. You're not going to like this next one at all. This one here, example 2. That was the only question, right? Yeah. Oh boy. X squared equals 3x plus 4. Complete the square. You're going to find after today, you probably won't complete the square on a question like this ever again. You'll use the quadratic formula, I guarantee it. But we're going to complete the square anyways, because you can see how ugly it is. Okay. Now, how do you want to complete the square on this one? Do you want to bring everything over to the left side, or do you want to keep the 4 over on the right? Should we do some more practice of that? Well, you have to do it anyway, so you might as well. But the only difference is, where's the 3x? Is it the 3x on the wrong side? Yeah, we need the x squared and the 3x on the left, and the 4, can it stay on the right? Yeah, you could if you wanted to, guys, just so you're clear on this. You don't write this down. You could do it like this. Oops. You could set it up and do it like that. But the only thing is then at the end, what are you going to have to move back? Whatever the number is over there, right? Because you're going to have to solve for it. Okay, so, but let's do it this one way we just did in the last question. So negative 3x, and we're going to keep the 4 on this side, right? All we're going to do is we're going to complete the square. Now, the only difference is, because we have the equal sign here, if we add something to this side, we have to add something to the other side. If we subtract something on the left, we subtract something on the right. That's the only difference on this completing the square. If that's going to screw you up, write yourself a little note. right? Because you're on opposite sides of the equal sign. What? Well, normally if the 4 was on this side, right, on the left side, you would add and subtract on the same side. But because they're on different sides, you have whatever you add on the left, you add on the right. Whatever you subtract on the left, you subtract on the right. It's a slightly different way of looking at it. It's the exact same procedure. The only difference is the sign. I just don't want to confuse you. Okay, so x squared minus 3x equals 4. Now think about this for a minute. Basically, we're putting something here and putting something here. Right? We're going to complete the square. We're turning this part of a binomial, we're going to turn it into a lovely trinomial that factors into a perfect square. Yeah. All right. It can work because the rule is still the same. Right? What number are we taking and dividing by 2? No? Negative 3. Okay, oh boy. We're actually taking negative 3, dividing it by 2, and doing what to it? Ew! It's a fraction! How many of you want to convert that to a decimal? Don't do it. Do not convert it to a decimal. You'll make your life super difficult. Well, normally you would take that negative 3 divided by 2 and then you'd square. What's negative 3 divided by 2? But what is it as a fraction? Negative 3 divided by... Does it change? Okay, now, this may seem stupid. Watch. I'm going to write out the exact same thing again. Right? But normally what would I write there? The division part, right? Wouldn't I? But I want to keep the steps the same, right? I want to do 3 steps. So that's why I'm keeping it exactly the same. I know it looks silly because I've just written down the exact same thing. But normally, for instance, if that was negative 4 over 2, you would write down there a negative 2, right? That's the next step. Okay, now, here's the tough question. Negative 3 over 2 squared. What's a negative times a negative? What's 3 times 3? 9 over 4. Okay. You'll see in a minute why I did that in 3 steps and why these 2 pieces are the same. I try to be consistent when I do my steps because I don't want to throw you off. Okay, now, here's the deal. What do I add right here? I add 9 over 4. Now, because we're on opposite sides of the equal sign, if I add 9 over 4 on the left, what do I got to do on the right? Add 9 over 4 on the right. Okay. Now, this actually factors into 2 perfect binomials. Now, here's the reason why I did that. In the past, I didn't even have to think. I just had to look at the middle term to determine which one it was. And what is our middle term here? Minus 3 over 2. So that's what goes in here. Minus 3 over 2, minus 3 over 2. Ooh. 4 plus 9 over 4. What's another way to write 4 as a denominator of 4? That's 4 over 1, right? What is it? 16 over 4, is that correct? 16 over 4 plus 9 over 4, is that right? Well, it's 4 over 1, right? Now just make it what? You could write 4 and... No, 6 and a quarter if you wanted to, right? Well, we can do that in a minute, but you'll see why I did it. You'll see why in a sec why I did this. Okay, now what about this? Can I combine this to 2 binomials? Sorry, one thing. What is it? X minus 3 over 2 squared. Now carefully here. What's 16 plus 9? 25 over 4. It's not nasty, actually. It actually works out beautifully. You know what? You got to get comfortable with using fractions. You can't be scared of fractions. So many of you switch it right to decimals, and that'll throw you it'll make it more difficult. Now, what did we do at the next step? How did we solve for x? We took the square root. Did we take the square root of both sides? Is that what we did? You do the same thing here. Square root of this side and square root of this side. Okay. Now, what is the square root of x minus 3 over 2 squared? What is the square root? X minus 3 over 2. Well, that's easy. Now, here's the question for you. The square root of 25 over 4. What's the square root of 25? What's the square root of 4? Well, that actually works out quite nice, isn't it? But what do I got to put in front of it? Plus or minus 5 over 2. Is that right? Yeah? All right. How many answers are there? 2. This one plus that, this one minus that. Okay, so let's do that. So what I'm going to do, now you'll see I often do this, it's the same thing when we solve for zeros, right? I'm going to split it. So one of them is x minus 3 over 2 equals 5 over 2, the positive, right? And the other one is x minus 3 over 2 equals negative 5 over 2. Well, this is just straight math, guys. I mean, these are basic fractions. How do you get rid of the positive 3 over 2 when it goes to the other side? The negative, it becomes positive. So x equals 5 over 2 plus 3 over 2. What's 5? 5 over 2 plus 3 over 2. X equals, Mr. Gerling, no, let me know. 8 over 2, which equals 4. Oh, that's weird. Hey, what about this one? X equals negative 5 over 2 plus 3 over 2. X equals negative 2 over 2, which is negative 1. That's kind of weird. Did those answers work out really nice? Okay, now you're really gonna hate me. I'm gonna show you something. The thing about math, and this is probably one of the hardest concepts of math, is we give you rules to do stuff, right? And you really struggle sometimes when we vary from what it looks like, and you try to apply those rules and you get lost, right? Is that common with what I teach? There's always an easier way to do something. And another part of it is trying to decide which way is the easiest way for you to do it. The quadratic formula on Wednesday that I'll show you works for everything. But it's not always the easiest way. Sometimes this is an easier way. But there's even an easier way still, sometimes. Now look back at the original quadratic. What was it again? It was x squared equals 3x plus 4. Right? Is that correct? Could you make this into a lovely little trinomial, all equal to 0? Okay, so do that for a second. So bring the 3x over to this side, bring the 4 over to this side. So what do you get? X squared minus 3x minus 4 equals 0. What's the first thing you should always try when you have a trinomial? Before you do any of this other stuff, what's the first thing you should always try? To do what? Because it's positive goes to the side, becomes negative. What was the original one? That's right, okay. What should you always try when you get a trinomial before you do anything? First off, take out a GCS if you can, right? That's always the first thing. What's the next thing you should try? Try to factor it. Try to factor it. What times what gives us x squared? X and x. The sign here in front of the 4 is negative, so that means the signs are different. Factors of 4. 1 and 4, 2 and 2. Do any of those subtracted give you 3? So negative 1, so 1 and 4. But we want it to be negative, so it's negative 4 and positive 1. Now, what are the answers? 4 and negative 1. What did we get? 4 and negative 1. Well, that was a heck of a lot easier. Is that always going to be the case? Is it always going to work? No. Here's the thing you have to learn, and this is a really hard concept to learn. If you get all this junk, I give you all these tools, you have to decide which one to use. But after we do the quadratic formula, I'm going to give you a little list of things to look for when you see these, right? First one's going to be GCF. Second one's going to be try to factor it. Third one will be this way, and the last one, always last resort, quadratic formula. Okay? The thing is, do you still have to know how to do this? Yeah, this is the math that you have to know how to do, right? There's always an easier way. All right, flip page. Example number 3. What? It's a super common way of doing it. Like you've already learned completing the square. We just did it a different way before. This is just a variation. Oh. Okay. Now, this is another way to look at it. Solve, find the zeros. It means all the same thing. Now here's the deal. We're going to do this by completing the square. But stop for a minute. What should you try first? Just for the sake of trying it. It may work. You may spend a minute trying to figure it out and it may not work. But you may save yourself a bunch of time. Should you try to factor it? Let's try. Let's just see. Okay, so now let's just try this. Negative 2x squared minus 5x plus 3 equals 0. What's the problem here? We got a... No, well, yeah, you actually do have to GCF it, but what are you taking out? A negative. You're taking out negative 1, right? Okay, so take out your negative 1. Okay, I just want to see if this is even going to work. So 2x squared plus 5x minus 3. Okay, so let's try this one. Equals 0. What are the only two factors of 2x squared? 2x and x. Well, that's tough. The only two factors of 3 are 1 and 3. We just have to figure out the order. And we want the middle to be 5. So 2 and 3 gives us 6 minus 1 gives us 5. Oh, which one is going to work? Okay, so 3 goes there, 1 goes there. And we want the 5 to be positive, so what goes in front of the 3? Positive, because that gives us our plus 6. Oh, well, so this actually does work. So what are our actual answers? One of them is going to be x equals a half and negative 3. Well, make it equal to 0. 1 goes through the other side, becomes positive, divided by 2, and negative 3. Okay. Wow, now if you knew that right away, you'd save yourself a ton of work. But we're still going to complete the square. But do we know what our answers are? Yeah, we know what our answers are before we even get going. So if we do it wrong and we get the wrong answers, we know we did something really wacky. Okay, so let's complete the square. Just because it's so much fun. Seriously. You guys go for parties on the weekends, this is what you should do it with your friends. Guys, let's hang out and complete the square. So much fun. Probably won't be your friends anymore, will they? Yeah, pretty much. Okay, so we're going to complete the square. And let's do it the way we've been doing it. We'll keep the x values on one side and we'll keep the constant on the other, because I just want to be kind of similar when we're doing this. Okay, so if we keep it all on one side, what is it? Negative 2x squared minus 5x. Move the 3 to the other side, becomes... No, positive already. Becomes negative 3, right? I'm just trying to be consistent. Could you keep the negative 3 on the left side and complete the square? Yeah, but then you'd have to move it back. Okay, what's the first thing to do? Yeah, you can actually, there is a GCF in this time. We want, when we're completing the square, do we want the x squared to be by itself? Do we want anything in front of it? No. So what do we have to divide by to get rid of whatever's in front of the x squared? Divide by what? Negative 2. You got to divide the whole thing by negative 2. Now this is where it gets weird because all of a sudden we're dealing with fractions again. Oh, crap. Okay. So what do we get though? X squared. Now careful. Negative 5 divided by negative 2. Negative divided by negative is a positive. So 5 over 2, x. Negative 3 divided by negative 2 is positive 3 over 2. That's not bad. Can handle that. Which one? No, because we're dividing negatives by negatives. I know. Okay. This is good practice actually doing with fractions, isn't it? So let's give ourselves some space, right? So x squared plus 5 over 2x equals 3 over 2, right? And we're going to add something here and here. I don't know if you noticed, I've done this now 3 times and I've done the exact same thing every single time. Now, what number am I dividing by 2? 5 over 2. Okay. Oh boy. This is going to look weird. So 5 over 2, what am I doing with it? Dividing by 2, and what am I doing with that number? Squaring it. Whoa, people really hate that. Fractions with fractions. It doesn't make any difference, guys. 5 over 2 divided by something is the same as multiplying by the reciprocal. I don't know, figure it out. So think about it this way. 5 over 2 divided by, divided by 2 over 1, right? Isn't that what that is? Isn't that 5 over 2 divided by 2? Isn't that what that says? 5 over 2 divided by 2? Which is 5 over 2 times the reciprocal, 1 over 2, which is 5 over 4. That's a basic math thing, but is it complicated? Is that going to throw you off? Yeah, did you get that? You got that wrong, twice before you got the right answer, right? Yeah, it's a tough one because you're trying to do it mentally, right? I find with something like that, if you're going to screw that up, write it out. So what does that equal? 5 over 4 squared, is that correct? We haven't done that yet. What's 5 over 4 squared? That's the easy one. 25 over 16. But you see, it looks weird, but I'm still doing the same 3 steps. They get more complicated, but I'm still doing the same 3 steps. So what do I add here? 25 over 16. So what do I add on this side? Same thing. In some ways, I think completing the square when you do it left and right side is easier, isn't it? Because you don't have to remember dealing with the positive and negatives. It's just the same thing, whatever it is. Okay, now, I'm going to jump steps because I'm tired of putting the next line in there as 2 binomials. I'm going to go right to the single binomial square because I actually find it easier. X, now look here, you don't even have to think. You just have to look of these 3 terms here, you just got to look at the one in the middle. And what is it? Positive 5 over 4. Well, that's tough. So plus 5 over 4. That's why I like doing that in that one step. Okay. Oh boy. What's with always adding a fraction? It's kind of horrible. Guys, common denominators. What's our common denominator? 16. What do you times 2 by to get to 16? 8. So what do you times 3 by? So what is that actual number? It's 24 over 16. Is that what it is? Plus 25 over 16. I really shouldn't have written that step out. I should have done that one in my head. But I'm writing it out just so you can see. So what did I do there? I times both those by, I times that by 8, I times that by 8. I'll write that in just so you see what we did there. Okay, so x plus 5 over 4 squared equals 24 plus 25? 49 over 16. Okay, now what do we do? Take the one side or both sides? Both sides. Oh boy, it's a lot of work, isn't it? Did you get lost in this work? Super easy. Yeah, you'll see in a sec. Okay, equals, now careful here. Square root of 49 over 16 is the plus or minus square root of 49? 7 over 4. Well, that's actually easy. Now, if we did this correctly, we know our answer is going to work out to, what was it again? Negative 3.5, right? Let's find out. So what do we do with both these? Split them, right? One's positive, one's negative. So one of them is x plus 5 over 4 equals 7 over 4, and one is x plus 5 over 4 equals negative 7 over 4. Right? Those are our 2 possibilities. I know I'm booking along here, guys. So x equals 7 over 4 minus 5 over 4, which is what? What's 7 minus 5? 2 over 4, which is half. Is that correct? Was that supposed to be one of our answers? Yeah. This one is x equals negative 7 over 4 minus 5 over 4, which is negative 12 over 4, which is negative 3. See, we did, but I mean, the thing is, like I said, there's multiple ways of doing this. You have to figure out the easiest way. It'll take tons of practice. All right, what time is it? Oh, we still got time. Last question. Sorry, last example. Okay, now, here it is. This is the ones I said before that we were going to be able to figure out eventually. Could you figure out the vertex, by the way, of this one? Could you figure out the vertex? Negative b over 2a, is that right? Then get x, plug it in, find out what y is. What we're looking for is the Savannah takes a soccer ball away from her own goal. The path of the soccer ball can be approximated by the quadratic formula, right? It's a big parabola. Where x is the horizontal distance traveled in meters from the goal line, and h is the height in meters. So what we want to do is we want to find out from where the ball is kicked to where it lands. We want to find that distance. So we want to find the x-intercepts. So we want to find the roots. So basically we want to take that sucker and factor it. Oy, oy, oy. That's a tough one to factor. Okay. We're going to complete the square of this. No, why not? Okay. So let's approach it the exact same way. What are we going to do? What do we want to do? We want to leave the 35.34 on one side and put all the other numbers on the other side. Is that correct? So there's a couple ways of doing that. You can move the 35, 34 over to the other side, or could you move both of those over? Does it matter? It doesn't matter. What do you want to do? Let's move the other two over. Perfect. Because that's actually equal to 0. So we move it over to the other side. Instead of negative 0.06, it becomes 0.06 x squared minus 3.168x equals negative 35.34, right? So all we did was move it over to the other side. Yeah? You could have left it all on one side and completed the square on the one side, but you know what? Do whatever you want. Okay. Now the key to doing this, to completing the square, is we need x squared by itself, don't we? Does it have to be by itself? The problem is what's attached to it? 0.06. So how do we get rid of it? Okay, so we got to take everything and divide it by 0.06. Oh boy. Oh, yucky. Ew. So we're going to take this whole thing, and divide by 0.06. Oh boy. Wow, we haven't done this yet. Oh, I'm scared. Well, the first one's easy. Okay. Do the next one for you. Negative 3.168 divided by 0.06. 52 point what? Whoa, that actually worked out quite nice, didn't it? Guys, the questions I give you, are they going to work out nice? Yeah, dang right. No, it's just the way it's set up, because we're not trying to make it really difficult for you. Negative 35.34 divided by 0.06. Negative, what is it? 58.9? Wow, that's actually not bad at all. Actually, I turned from a really ugly question into quite a nice question, didn't it? No, that's not right. 5.06? It's 589. Decimal place is in the wrong one. Trying to confuse me. Okay. Now guys, even though the numbers are nice numbers, really like nice integers, right? And it's not fractions, which worked out really nice, we still do the same thing, right? We're still going to take this number here, this negative 52.8, divide it by 2 and square it. And then whatever we do to one side, we're going to do to the other. Big deal. So let's treat it exactly the same way. So I'm going to give myself a little bit of space here. Right? Equals negative 589. Okay. I'm going to put something here, and I'm going to put something here. There's my two lines. Exact same procedure as we've done. Nothing has changed other than the numbers. What number am I dividing by 2? Careful. Negative. I didn't give myself room here at all, did I? Can I do a little bit lower? Is that okay? Will that throw you off if I do it just below it? Hopefully not. Negative 52.8 divided by 2. And what are we going to do with this number? Oops. What are we doing with this number? Problem is this left side of the board is so out of whack. Negative 52.8 divided by 2. We're going to square it. What is that? Negative 26.4 squared. What's a negative times a negative? Positive. So we end up with, what is it? 696.96? Is that correct? Double check my math, please. Sorry? You got that? Okay. So if you add 696.96 here, what do you do here? I have 696.96. What do you think the most common mistake is when you do completing the square like this? You're going to subtract. You're going to go back to the rules of when it was all on the same side, right? And you really got to make a note for yourself. If it's all on the same side, it's add and subtract. If it's on different sides, it's the exact same sign, right? That's got to be a key thing. Okay, I'm jumping right to my straight binomial. X, I don't even have to look. I don't even have to think. I just got to look. What is it? Negative 26.4 equals, can you do the math there? Negative 589 plus 696.96 is, what is it? 107.96? Okay, what do we do next? Same thing. Square roots. Both sides, right? Square root. Square root. So x minus 26.4 equals, oh shoot. Does that work out nicely? No. So do we leave it in that form? The only thing is, one is positive and one is negative. So we just put our plus and minus there. Is that a common mistake to forget too? Yeah, I see that all the time. No, it's actually not that bad because sorry, what? No, that's even easier. So what do you do here? X minus 26.4 equals 107.96 square root, and x minus 26.4 equals negative 107.96. Give me the numbers, by the way. I think these are approximations. I don't think they work out actually quite nice. What are the odds? Guys, you know, this goes to the other side, it becomes positive, right? The 26.4. So 107.96. What is it? 36.8 is the first one. And this one is? Is that what it is? Yeah? You got to be able to do the math. If you can't do the math for this, then boy, you're in trouble. Think about what this actually is. How far away from the goal was she when she kicked the ball? No, how far away from the goal? 16 meters. She kicked the ball. How far did it go? What line did it hit? 36.8. So can we figure out how far she kicked it? How'd you get that, though? Yeah, you subtract the two of them, right? So this is part B, right? This is actually what the horizontal distance is. You take the 36.8, subtract the 16.0, and you get what? 20.8 meters. So she kicked the ball almost 60 feet. So what was A then? How far away was she from the goal line? She was 16 meters from the goal line. Like if you actually look at this as a parabola, it's going to look something like that, right? This point here is 16. That point there is, what'd you get? Did you take the square root of one? Which one are you doing? This one here? Negative, do 107.96 and then make it negative. And then add 26.4 to it. Oh, it's negative because it's negative, right? Well, the negative 107 has to be greater than 10. Oh, okay. But that's what the parabola looks like in this case, right? Because if you look at this, go back to the original equation, what's the y-intercept? Negative 30.434. So on this graph, if we actually drew, here, I'll draw a better one here. If you actually graph this out, this point right here is negative 35, what was it again, 35.34, right? This point here is 16.0, and this point here is 36.8. That's what that graph actually looks like, right? That parabola. This is a question you couldn't do before, right? You didn't have the skills to actually figure those out. Now do you have the skills? You could do it that way. Now, what I'm going to show you is Wednesday, again, the quadratic formula. You might find that's even a faster way to do it. Because with the quadratic formula, you can go right from this guy here and plug it right into a formula. And then you can get the answers. But the math is still the same because you're still going to end up, when you finally do this, you're still going to end up with two answers, one positive, one negative. Sorry, what? Yeah, you're going to end up with this at the bottom. You end up with the same thing. It's just a different way of doing it. The problem with the thing about the quadratic formula, it works for stuff that's non-factorable, right? Because like some of the examples we did, is there an easier way? And sometimes you can take out a GCF and do it straight factor. Well, wouldn't it be nice to know how many answers there are before you even start? I'm going to show you that. There's a way to figure out whether there's one answer, two answers, or no answers, right? Because think about a quadratic, right? If a quadratic's in quadrant 1 and it opens up, is there any x-intercepts? No, it's way above everything, right? If it comes and touches the x-axis at one point, there's one answer. In this case, this one, how many answers are there? 2, because it crosses the axis at 2 points, right? So if you know beforehand how many answers there are, it'll help you kind of pick the method that you're going to use to solve this. Yeah? Okay. Anyways, tomorrow's a word class, so we're going to spend all class doing on this. Let me give you the questions right away. Let me stop this first. Hang on.